All right, so next let's move on to n-dimensional spaces. I think I need to move this down a little bit. Okay, so we have vectors in Rn here. R1 space means one-dimensional space. So if you were to plot vectors in R1 space, they would be just one-dimensional things. So they would go, this is R. They would go on the real on the number line, right? So that's R. R2, we just graphed a bunch of things in R2. We have our x and y coordinates. In three-dimensional space, we have, so in R3, if you're in Calc 3, then you've been graphing things in 3 dimensions there. So it's going to be much harder to draw vectors in R3. And we really can't draw anything past R3. So 4-dimensional space or n-dimensional space, we can't really draw that. But that has applications in a lot of fields, although, so we can translate a lot of problems into have problems with several coordinates. So this doesn't mean that it does, just because we can't draw an n-tuple doesn't mean it doesn't have any important applications, because it does. Okay, so an n-tuple is really a vector that has n components. So here's an n-tuple right here. So we have components from x1 to xn. So let's look quickly at the definition of addition and scalar multiplication. So if you take an n-tuple or a vector u in Rn and a vector v in Rn, and c is a real number or a scalar, then the sum of u plus v is defined just like we did in R2. So now we have more components to add up, but that's fine. And the scalar multiple of u, cu, is defined by multiplying each component by c. Now, we also should talk about properties of vectors in Rn. So now, for they're exactly the same properties that we just talked about for R2, but now our vectors are n-tuples instead of ordered pairs. So the proofs of these properties get done exactly the same way. So I'm not going to show any, but if you have questions about how to do those, because we did this with matrices, we did this with vectors in 2 dimensions, hopefully you did this in Calc 3 with vectors in 3 dimensions, and now you just have to do ... vn or un or whatever the vector is. Okay, what I am going to prove is some properties of the additive identity and the additive inverse. And I am going to start that in just a second because I need to put something up on the board.